You ever find yourself staring out of an airplane window at like 30,000 feet and just think, how? Well, in this explainer, we are diving deep into the reliable physics of flight, or as I like to call it, how these super heavy metal planes manage to politely refuse to fall down. Let's get into it.
All right, let's just ask the question straight up. How does a 400,000 kilogram machine that's made of metal, filled with people, luggage, and let's be real, some pretty questionable coffee, how does that thing just hang out in the sky? I mean, it kind of feels like it defies all common sense, right?
Well, the short answer is pretty simple, and maybe a little bit smug. It's just physics. That's it. It's not some kind of magic trick, it's not good luck, it's just a set of really, really reliable rules doing their job.
But I know you're not here for the short answer. You want the real deal. So, let's get into the long answer. Let's break down exactly how those rules of physics work together to make the miracle of modern flight even possible.
Okay, so it all starts with these four fundamental forces. Honestly, the best way to think about them is like a team, where each member has a super specific job. So let's meet the crew responsible for keeping that plane where it belongs, up in the air.
So, this is the team. First up, you've got lift. Lift is our hero, always pulling upwards, created by the wings to keep the plane from, becoming a very expensive crater. Fighting against lift is weight, the villain of our story, always trying to pull the plane down thanks to gravity. Then you have thrust, that's the motivator, the engines pushing the plane forward. And finally, there's drag, the complainer, always trying to slow things down, just air resistance being annoying.
Now, for a plane to fly nice and smooth, in a straight, level line, these forces have to be in a perfect state of balance. Lift has to be exactly equal to weight, and thrust has to be exactly equal to drag. It is a constant tug-of-war in the sky, and balance is everything.
Okay, so out of all those forces, there is one that's the undeniable MVP of the team, and that's lift. So how in the world do the wings, our hero's secret weapon, actually generate this incredible upward force? It all comes down to their really unique shape.
The magic, if you want to call it that, is all in the shape of the wing. It's called an airfoil. And if you look at it, you'll see it's curved on the top and much flatter on the bottom. Now that shape isn't just for looks. It is a brilliantly engineered air negotiation device designed specifically to manipulate the air that flows over and under it.
So one part of the explanation comes from this guy named Bernoulli. His whole principle is that faster-moving air has lower pressure. Now because of that curved top of the wing, the air traveling over it has to go a longer distance, so it speeds up. This creates a low-pressure zone above the wing, while the slower air underneath has higher pressure. And that difference in pressure basically pushes and sucks the wing upwards.
But here's the thing. The explanation that really carries the most weight, pun intended, is actually way simpler, and it comes from Sir Isaac Newton. You know his third law. For every action, there's an equal and opposite reaction. Well, a wing is angled just right to push a massive amount of air down, and in reaction to that, the air pushes the wing up. It's really as simple as that.
And look, while Bernoulli's idea definitely plays a part, the main reason a plane has lift is because of that simple action-reaction. The wing is basically a giant air deflector. It pushes air down, so the air pushes the wing up. No contest. Newton wins this round.
Of course, there's a formula for all this, but don't worry, we're not going to do any math here. The ingredients are what's important. To figure out how much lift you have, you just need to know the air density, the size of the wings, and probably most importantly, the plane's speed or velocity.
But here is the absolute key to that whole equation. See that little 2 next to the v for velocity? That means speed is squared, and that makes it the single most powerful factor by far. So if you double the speed of the plane, you don't just double the lift, you get 4 times the lift. This is exactly why airplanes need those super long runways.
So now that we've met the team and we understand our star player, Lift, let's see how they all work together to achieve that perfect balance we need to actually get off the ground. Let's put these forces to work. Which, brings us right back to that voice in the back of your head. I can hear it now. But the plane is so heavy. And you're right, the weight is just enormous. So how can a simple push from the air overcome all of that mass? Well, here's the secret. Physics doesn't really care how heavy the plane is. All the weight does is set the target. It tells you how much lift you need to generate to beat gravity. And you get there by flying really, really fast, having really big wings, and building the plane out of materials that are both strong and light. The weight isn't a barrier, it's just the number you have to beat.
And this is a super important point that a lot of people get wrong. The engines are not lifting the plane. They're not. They are the motivators. Their only job is to create thrust to shove the plane forward at incredible speed. Think of them like a personal trainer at the gym. They don't lift the weight for you, but they're screaming at you to run fast enough so that your wings can do the actual lifting.
So let's put it all together. Here's takeoff step by step. First, the engines fire up, creating massive amounts of thrust. The plane starts screaming down the runway, and its airspeed climbs higher and higher. As that speed goes up, remember our formula. The lift from the wings increases like crazy. And then you hit that magic moment where lift becomes greater than weight, and you have liftoff. And for a little while at least, gravity is very, very offended.
So, to wrap things up, let's just quickly bust a few common flight myths. It's time we get clear, once and for all, about what's really happening up there. Let's be crystal clear. Planes do not float on air like a boat floats on water. The engines are not lifting the plane. Here's what's actually happening. The wings are designed to push a huge amount of air downward. In response, the air pushes the wings upward. That's the whole game. And the best part, physics works every single time.
And that's really the thing to remember. Flying would be absolutely terrifying if it wasn't for these unbreakable rules. Fortunately, physics is incredibly reliable and it does not skip lectures. And that, right there, is why a 400,000 kilogram tube of metal can soar so gracefully through the sky.